This is gonna blow your mind. Welcome to Cosmic Chronicles, your ultimate guide to the universe. Imagine everything you know squeezed into a space smaller than an atom. That's the Big Bang. About 13.8 billion years ago, our universe began as an incredibly hot, dense point. It wasn't an explosion in space, but rather an expansion of space itself. As you inflate the balloon, the dots move farther apart. Similarly, the Big Bang stretched space, carrying galaxies along for the ride. We know this because distant galaxies are moving away from us. Everything we see, from stars to atoms, originated from this single event. In the first fraction of a second after the Big Bang, the universe was a chaotic soup of energy and particles. As the universe expanded and cooled, energy condensed into matter and antimatter. But I have to stop you guys today to tell you guys about our new channel, History Guy. You can view the channel in the link below. Wait, where was I again? Oh yeah, this excess of matter formed the building blocks of our universe. This period, known as baryogenesis, is crucial in the universe's evolution. The early universe, though filled with light, was far from uniform. Tiny fluctuations in density, perhaps caused by quantum effects in the first moments after the Big Bang, created regions with slightly more mass than others. These denser regions exerted a slightly stronger gravitational pull on their surroundings. Over millions of years, gravity amplified these tiny differences. Matter clumped together, forming vast clouds of gas and dust. These clouds, drawn together by their own gravity, continued to collapse, becoming denser and hotter over time. This process, driven by gravity, marked the transition from a smooth, almost featureless universe to one with structure and complexity. The seeds of galaxies, stars, planets, and ultimately, life itself, were sown in these early density fluctuations. These clumps of matter, drawn together by gravity, formed the building blocks of larger structures. Smaller clumps merged to form larger ones, eventually giving rise to the first galaxies, vast collections of stars, gas, dust, and dark matter, bound together by their mutual gravitational attraction. Within these collapsing clouds of gas and dust, temperatures and pressures soared. At the cores of these dense regions, a remarkable transformation took place. Hydrogen atoms, the simplest and most abundant element in the universe, were forced together under immense pressure. This process, known as nuclear fusion, released tremendous amounts of energy, igniting the first stars. These stars, much larger and hotter than our own sun, bathed the surrounding gas and dust in intense ultraviolet radiation. The birth of these first stars marked a turning point in the evolution of the universe. They flooded the cosmos with light and heat, ending the cosmic dark ages. More importantly, these stellar furnaces forged heavier elements in their cores. As stars age, they convert hydrogen into helium through nuclear fusion. This process releases energy that powers the star. When a star runs out of hydrogen fuel, it begins to fuse helium into heavier elements such as carbon, oxygen, and eventually iron. Section 5. Galaxies assemble islands in the cosmic ocean. As stars ignited and died, they enriched the surrounding gas with heavier elements. These elements, scattered into space by stellar winds and supernova explosions, became the building blocks for future generations of stars and planets. The first stars were not solitary wanderers. They formed in clusters, bound together by their mutual gravity. These star clusters, in turn, interacted and merged with other clusters, gradually assembling into larger and more complex structures, galaxies. Galaxies are vast islands of stars, gas, dust, and dark matter held together by gravity. They come in a variety of shapes and sizes, from majestic spirals like our own Milky Way to elliptical giants and irregular dwarfs. These galactic metropolises are not randomly scattered throughout the universe. Gravity draws them together into groups and clusters, forming a vast cosmic web of interconnected structures. Section 6. Our Cosmic Cradle, the Birth of the Solar System. About 4.6 billion years ago, in a remote corner of the Milky Way galaxy, a giant molecular cloud of gas and dust began to collapse. This cloud, perhaps nudged by the shockwave from a nearby supernova, contracted under its own gravity, spinning faster and faster as it shrank. At the center of this swirling cloud, a protostar, destined to become our sun, ignited. bathing the surrounding disk of gas and dust in light and heat. Within this protoplanetary disk, dust grains, held together by electrostatic forces, began to clump together, forming larger and larger aggregates. These aggregates, called planetesimals, continued to grow through collisions, gradually accreting into planets. Closer to the Sun, where temperatures were higher, only rocky materials could condense. These materials formed the inner terrestrial planets: Mercury, Venus, Earth, and Mars. Farther out beyond the frost line, ices and volatile compounds could also condense, forming the gas giants: Jupiter, Saturn, Uranus, and Neptune. Section 7. A pale blue dot, Earth's remarkable journey. Earth, our home planet, formed in the habitable zone of our solar system, a region where temperatures are just right for liquid water to exist on the surface. This simple fact has had profound consequences for the evolution of life. Early Earth was a hot volcanic world, constantly bombarded by asteroids and comets. Over time, Earth's surface cooled and oceans of liquid water formed. The presence of liquid water, along with a protective atmosphere, set the stage for life to emerge. The early Earth's atmosphere was very different from what we breathe today. It was rich in carbon dioxide, methane, and other greenhouse gases. These gases trapped heat, keeping the planet warm enough for liquid water to exist. As life evolved and diversified, it began to alter the Earth's atmosphere. Photosynthetic organisms like cyanobacteria released oxygen as a byproduct of photosynthesis. Over billions of years, this oxygen accumulated in the atmosphere, transforming it into the oxygen-rich environment we depend on today. Section 8. Cosmic Exploration, Unveiling the Universe's Secrets. For centuries, humans have gazed up at the night sky, filled with wonder and curiosity about the cosmos. With the advent of telescopes, our view of the universe expanded dramatically. We discovered that our Sun is just one star among billions in the Milky Way galaxy, and that our galaxy is just one of countless galaxies scattered throughout the vast expanse of space. The 20th century witnessed an explosion of astronomical discoveries. We learned about the expansion of the universe, the Big Bang Theory, the existence of black holes, neutron stars, and other exotic objects. Space exploration has taken us beyond the confines of Earth, allowing us to study other planets and moons in our solar system up close. We've landed rovers on Mars, sent probes to the outer planets, and even walked on the Moon. These missions have provided us with invaluable data about the formation and evolution of our solar system, the search for extraterrestrial life, and the origins of the universe itself. Section 9. The Expanding Universe. A never-ending story. In the 1920s, astronomer Edwin Hubble made a groundbreaking discovery. The universe is expanding. By observing distant galaxies, he found that they are moving away from us, and the farther away they are, the faster they are receding. This observation implies that the universe was once much smaller and denser than it is today, supporting the Big Bang Theory. The expansion of the universe is not like an explosion, where objects are flung outward from a central point. Instead, it's the fabric of space itself that is stretching, carrying galaxies along for the ride. The rate of expansion is not constant. In the late 1990s, astronomers discovered that the expansion of the universe is actually accelerating, driven by a mysterious force called dark energy. Section 10. The Future of Space Exploration, Unraveling Cosmic Mysteries. As we continue to explore the universe, new mysteries and questions arise. What is dark matter, the invisible substance that makes up the majority of the universe's mass? What is the fate of the universe? Will it continue to expand forever, or will it eventually collapse upon itself in a big crunch? Future space missions, such as the James Webb Space Telescope, promise to revolutionize our understanding of the universe. With its unprecedented sensitivity and resolution, the James Webb Space Telescope will peer deep into the early universe, observing the first stars and galaxies forming after the Big Bang. We are on the verge of a new era of space exploration, one that will see us venturing farther into the cosmos than ever before. With advances in technology and our insatiable thirst for knowledge, we are poised to unlock the secrets of the universe and our place within it. Section 11. Keep looking up, the universe awaits. The universe is a vast and awe-inspiring place full of wonder and mystery, From the smallest subatomic particles to the largest galaxies, everything is connected in a grand cosmic dance. Our journey of cosmic exploration has just begun. As we continue to explore and learn, we will undoubtedly make new discoveries that will challenge our understanding of the universe and our place within it. So keep looking up at the night sky and never stop asking questions. The universe is waiting to be explored. If you're eager to learn more about the universe and its mysteries, I encourage you to check out my YouTube channel, where I delve into these topics and more. You can find it at https:/youtube.com/@aguyfrom1800 =KT Nico W KLSPNJM9. Let's explore the cosmos together.